This morning we're doing a couple of vapor pressure demonstrations. We have a pot of boiling water on the stove that contains a somewhat empty bottle, has a small amount of water in it. We're going to check the temperature right here and see that it is pretty close to 100. Then we're going to check the temperature of the boiling water and see what that is. And that appears to be slightly above 100 degrees, say about 104, nope, 103 degrees. So on this day, water is boiling at 103 degrees. That would probably indicate the air pressure is a little bit above normal atmospheric pressure. What we're going to do is take this bottle and place it into a ice bath. Now if we did that, normally it would break the bottle, but what we're going to do is invert the bottle's mouth or the neck of the bottle into the ice water, and the bulk of the bottle will be out of the ice water, so hopefully it won't break. And then as it cools down, the water should come up inside the bottle, because at the moment the air inside and the vapors inside the bottle are pretty close to 100 degrees, and the vapor pressure of water at that temperature is about the same as atmospheric pressure. But as we cool it down, the vapor pressure should drop significantly, and the pressure outside the bottle should be greater than the pressure inside the bottle, making the water go up into the bottle. Alright, let's see what happens. Well, the bottle didn't break, and indeed, as it starts to cool down, the water is starting to go up inside of the bottle. Now we'll just let that continue to cool and see how far the water will in fact go up inside the bottle. The bottle at this point is still quite hot. But we're just going to slowly let it cool down and see how much water actually gets pushed up into the bottle. In fact, what we can do here is probably add a little bit of ice to the top of the bottle, assisting the cooling process a little bit, not too much, otherwise the bottle could actually crack. But it's a pretty thick bottle, so I think it can handle a little bit of temperature differential. But definitely the water is going up into the bottle as it cools down. We'll just let it sit for a bit. In fact, that the water is slowly rising as the air inside, or the water vapors rather, inside start to condense and the pressure decreases. The pressure on the outside remains atmospheric pressure. Still cooling, and water is still rising very slowly. Where's the level? There it is. Water is still rising very slowly, as we think we had mostly water vapor inside. If there was in fact some air, which I'm sure there was, we will not be able to get it to go all the way.